Welcome back to another video by Adeptus Academy. Every time you flip a light switch or charge your phone, an invisible force springs into action: electromagnetic energy. It powers our cities, devices, and daily lives. This energy is born from the partnership of electricity and magnetism, discovered by pioneers like Michael Faraday. Move a magnet near a wire and you create electricity, a principle behind our entire power grid. Spinning turbines and rushing water transform motion into the electricity that powers our world. Let's uncover the science behind this invisible force and see how it keeps our world running. Let's travel back to the age of the dynamo, the first machine to generate electricity on an industrial scale. Before dynamos, electricity was a scientific curiosity, produced in tiny amounts by batteries. The dynamo changed everything, turning electromagnetic induction into a practical machine that could light up entire cities. A dynamo converts mechanical energy, like a spinning wheel, into direct current, DC electricity. Its design is simple. A stationary magnet, the stator, creates a magnetic field while a spinning coil of wire, the armature, cuts through that field. As the armature spins, it generates an electric current. The commutator, a clever switch, ensures the current flows in only one direction, producing smooth DC power. Dynamos powered the first electric lights, streetcars, and factories, transforming daily life. Though largely replaced by newer technology, the dynamo's principle remains foundational. Understanding dynamos is like reading the first chapter in the story of electricity. They showed the world what was possible. A dynamo transforms motion into electricity, powering much of our world. When something spins the armature, like a bicycle or steam engine, it moves a coil of copper wire inside a magnetic field. This motion pushes electrons through the wire, generating current. The faster it spins, the more electricity is made. A commutator and brushes ensure the current flows in one direction, DC, perfect for early electric devices. The dynamo's simple, brilliant design sparked the electrification of cities, homes, and industries, changing history forever. Fast forward to the alternator, the modern powerhouse of electricity generation. While dynamos were pioneers, alternators are the efficient workhorses running our world today. Most of the electricity powering homes and industries comes from massive alternators and power plants. Alternators, like dynamos, use electromagnetic induction, but they produce alternating current, AC, instead of DC. AC rapidly changes direction, 60 times per second in the US, and this has huge advantages. The voltage of AC can be easily changed with a transformer, making it ideal for long-distance transmission. High-voltage AC travels efficiently over power lines, then is stepped down for safe use in homes. Alternators naturally produce AC, eliminating the need for a complex commutator. You'll also find alternators in cars, where they generate electricity to power electronics and recharge the battery. Without the alternator, your car's battery would quickly die. Alternators are compact, powerful, and essential to modern life. They're the heart of our global power grid. Let's peek inside an alternator. The key principle is the same. Move a magnetic field past a wire coil to generate electricity. In alternators, the magnet, rotor, spins inside stationary coils, the stator. As the rotor spins, its magnetic field sweeps past the stator, inducing an alternating current. This design allows for direct connection to the grid, with fewer moving parts and less wear. Alternators can be built larger and spin faster, making them more powerful and reliable than dynamos. That's why they're the go-to choice for everything from power plants to cars. Place a dynamo and an alternator side by side, and you'll notice a fundamental difference: the type of current they produce. These two machines may look similar at first glance, but their inner workings and the electricity they generate set them apart in fascinating ways. Dynamos generate direct current, or DC, which flows in only one direction. This is made possible by a clever device called a commutator, which acts like a one-way valve for electricity, ensuring the current always moves the same way through the circuit. Alternators, on the other hand, produce alternating current, or AC. In AC, the direction of the current reverses periodically, which is a natural result of the alternator's design. This makes alternators simpler, more robust, and easier to maintain than dynamos. In dynamos, the spinning coil, called the armature, works together with the commutator, but this setup creates friction and wear over time. The commutator's constant contact with brushes means regular maintenance is needed, and efficiency can drop as parts wear out. Alternators flip the design. Instead of spinning the coil, they spin a magnet inside stationary coils. This clever arrangement produces AC and eliminates the need for a commutator, reducing friction and mechanical losses. With fewer moving parts and less wear, alternators are more reliable and efficient. They can also be built larger and more powerful, making them ideal for everything from cars to massive power plants. In the early days of electricity, dynamos powered many DC devices and small networks. But as cities grew and the need for long-distance power transmission increased, alternators became the clear choice for large-scale generation and distribution. Today, even when we need DC for electronics or batteries, it's usually more practical to generate AC with an alternator and then convert it to DC using a rectifier. This approach is more efficient and cost-effective for most applications. The choice between dynamo and alternator depends on the application, but for our modern AC power grid, alternators are the backbone, delivering electricity to homes, businesses, and entire cities. That's why alternators have replaced dynamos in almost every field, from cars to power stations, leaving dynamos as relics of a bygone era. The evolution from dynamo to alternator has shaped the way we generate, distribute, and use electricity, powering the modern world as we know it. You can still spot both dynamos and alternators in action if you know where to look. Classic dynamos power old bicycle lights. A small device rubs against the tire, spinning a magnet inside a coil to generate DC for the headlight. Hand-cranked emergency radios and flashlights use tiny dynamos. Turn the crank, and you generate your own power. These devices are perfect for emergencies, showing how motion becomes electricity. Alternators, meanwhile, are everywhere in modern life. The most familiar is under your car's hood, where a belt spins the alternator to power electronics and recharge the battery. Without it, your car's battery would die quickly. On a grand scale, power plants use giant alternators to generate the AC that flows into your home. Whether powered by steam, water, or wind, the final step is always spinning a turbine connected to an alternator. These machines are the beating heart of our civilization's power supply. They keep our world running. Why does it matter if you know the difference between a dynamo and an alternator? Because these machines are the foundation of our modern world. Every time you use electricity, you're relying on their ingenious design. Understanding them helps you appreciate the energy we use and the innovation behind it. It also empowers you to join conversations about energy, sustainability, and the future. This knowledge can spark curiosity, inspire invention, and help you make sense of the technology all around you. In a world powered by complex systems, knowing how things work is a superpower. The dynamo and alternator transformed civilization, turning motion into electricity and lighting up the world. Their impact is everywhere, from hospitals to global communication networks. As we face climate change, we're finding cleaner ways to spin the rotors of our alternators. Wind, water, geothermal, and solar. The generator remains key, even as our energy sources evolve. Faraday's discovery of electromagnetic induction still powers our future. Engineers are making generators smaller, more efficient, and more durable, exploring new materials like superconductors. The dance of spinning magnets and coiled wires continues to light our way forward. One brilliant idea changed the world, and its spin hasn't stopped.